So I am P. Iswara Devabalan, Department of Civil Engineering, Rohini College of Engineering and Technology. Subject strength of materials, subject code CE3491, Regulation 2021. The topic elastic constant. Longitudinal strain. When a body is subjected to an axial tensile or compressive load, there is an axial deformation in the length of the body. The ratio of axial deformation to the original length of the body is known as longitudinal strain or linear strain. The longitudinal strain is also defined the deformation of the body per unit length in the direction of applied load. L is equal to length of the body and P is equal to tensile force. Del L is equal to increase in the length of the body in the direction of load P. Therefore, the longitudinal strain is equal to change in length divided by original length. Then next topic, lateral strain. The strain at right angles to the direction of applied is known as lateral strain. Let a rectangular bar of length L, breadth B and depth D is subjected to an axial tensile load P as shown in figure. The length of the bar will increase while the breadth and depth will decrease. Let del L increase in length and del B decrease in breadth and del D decrease in depth. The longitudinal strain is equal to change in diameter or divided by original diameter, or change in breadth divided by original breadth, or change in thickness divided by original thickness. Then elastic constant. There are three types of elastic constant. They are modulus of elasticity or Young modulus, that's the symbol of capital E, and shear modulus or modulus of rigidity, that is the symbol of C or G or N, and bulk modulus symbol K. Then modulus of elasticity or Young modulus. The ratio of linear strain to the corresponding linear strain is a constant. This ratio is known as the Young modulus or modulus of rigidity and is denoted by cap C. Therefore, T is equal to linear strain, capital E is equal to linear stress divided by linear strain. That is the sigma divided by small e. So next, modulus of rigidity or shear modulus. The ratio of shear stress to corresponding shear strain within the elastic limit is known as modulus of rigidity or shear modulus. This is denoted CRG or N, that is the formula shear stress divided by shear strain. That is the symbol of dou divided by. Finally, bulk modulus. When a body is subjected to a mutual perpendicular like and equal direct stresses, the ratio of direct stress to the corresponding volumetric strain is found to be constant for a given material when the deformation is within a certain limit. This ratio is known as bulk modulus and is usually denoted by K. Mathematically, the bulk modulus is given by K is equal to direct stress divided by volumetric strain. Then next, Poisson ratio. The ratio of lateral strain to the longitudinal strain is a constant for a given material when the material is stressed within the elastic limit. This ratio is called Poisson ratio. The Poisson ratio mu is equal to lateral strain divided by linear strain. Therefore, lateral strain is equal to Poisson ratio mu into linear strain. The value of Poisson ratio varies from 0.25 to 0.33. For rubber, its value ranges 0.45 to 0.5. And problem, determine the change in length, breadth, thickness of steel bar, which is 4 meter long, 30 mm wide, 20 mm thickness, and is subjected to an axial full of 30 kilonewton in the direction of its length. Take E is equal to 2 into 10 power 5 Newton per mm square and Poisson ratio is equal to 0.3. And given data, The length of the bar L is equal to 4 meter, that is converted to mm in 1000, therefore 4000 mm, and breadth of bar B is equal to 30 mm, and thickness of bar T is equal to 20 mm, P is equal to 30 kilonewton, that is the load converted to Newton, so 30 into 1000, so 30,000 Newton. Young modulus E is equal to 2 into 10 power 5 Newton by mm square, and the Poisson ratio mu is equal to 0.3. So find the change in length, change in breadth, change in thickness. So first find out the stress. Stress is equal to load by area. Area, you know that rectangular section, breadth into thickness. So breadth 30 into 20 are given. So substitute value, answer is 600 mm square. Then stress is equal to load by area. So answer 50 Newton per mm square. So that is the load value 30,000 divided by area 600. So answer is 50 Newton by mm square. So we know that Young modulus is equal to cap C is equal to stress by strain, and strain is equal to stress divided by Young modulus. So substitute the value. So strain is equal to 2.5 into 10 power minus 4. That is no unit. The next change in length. So change in length formula, strain another one formula, change in length divided by original length. Therefore find the change in length. The change in length is equal to original length into strain. So substitute the value. So answer is 1 mm. And change in breadth, we know that Poisson ratio mu is equal to lateral strain divided by linear strain. So lateral strain is equal to linear strain in the Poisson ratio. So this two value, you know that linear strain, that is the small e value, and Poisson ratio, that is the given for mu Poisson ratio. Okay. Next, substitute the two value. So 7.5 into 10 power minus 5. The next, lateral strain, change in breadth divided by original breadth. So find the change in breadth. Therefore change in breadth is equal to del B is equal to B in the lateral strain. So answer is 30 into 7.5 10 power minus 5. So answer 0.00225 mm. The next, change in thickness. So lateral strain divided is equal to change in thickness divided by original thickness. Therefore change in thickness is equal to original thickness in the lateral strain. So 20 into 7.5 into 10 power minus 4. So answer is 0.0015 mm. Thank you.